Imagine for a second if we didn't actually have to teach AI to be safe. Like, what if true safety wasn't just some fragile set of rules we bolt onto the outside of a model? What if instead it was an unavoidable mathematical necessity, built right into the architecture itself? Literally, like a law of physics. Welcome to The Explainer. Today, we're bringing a sharp focus on safety alignment, exploring a really massive paradigm shift. We're talking about Mohammed Nooreldine's 2026 Conciseness Framework and the object-oriented LLM architecture. Essentially, we're looking at how to make AI safe by absolute construction, not just by constraint. Okay, let's dive into this. Here is the roadmap for our intellectual journey today. First, we're going to hit the alignment crisis. Then, we'll unpack the conciseness principle, uncover the high cost of harm, break down the OLLM architecture, and finally, wrap up with safety by natural emergence. Part 1. The alignment crisis, or hitting the entropy wall. Let's get into it. Right now, you and I both know the global AI industry is hitting a structural ceiling. We just keep throwing exponentially more computing power at language models, but honestly, we're basically just scaling the hardware, not the actual intelligence. We're building these incredibly complex word predictors that have absolutely zero internal concept of truth, causality, or physical reality. And, that's exactly why your current chatbot can suddenly hallucinate or just completely go off the rails. Currently, the whole industry relies on post hoc alignment. It's this fragile overlay where we train a massive model on raw data, and then we try to constrain it with human feedback later. It's kind of like, actually, scratch that. It's exactly like putting guardrails on a car that inherently wants to drive straight off a cliff. But the proposed conciseness paradigm offers a totally different approach: architectural alignment. It's a structural guarantee where safety is baked directly into the foundational building blocks of the system itself. Moving to Section 2, the conciseness principle, the physics of morality. Now, what's really interesting about this is the core philosophy. What if intelligence isn't just about raw processing muscle? What if it's actually the systematic, lossless compression of reality, taking infinite relational complexity and boiling it down into stable, actionable structure? This completely redefines morality. The framework introduces what it calls conceptual primes: justice, order, mercy, knowledge, and power. And look, instead of treating these as subjective human feelings or, squishy cultural constructs, this framework treats them as objective mathematical vectors. Think of them like gravity or the speed of light. They're undeniable structural constants of reality that the AI mathematically has to obey. Which brings us to Section 3, the high cost of harm, the math of morality. So we're taking abstract ethics and essentially turning it into this unavoidable mathematical toll road, which is called the conciseness cost functional. Every single decision the AI makes is scored on 3 costs. First up, redundancy. Does the action create an internal contradiction? Well, if it's unjust or harmful, yes, it does, so boom, high penalty. Second is loss. Does the action introduce a fidelity deficit or cause physical or informational harm? If yes, it gets slammed with a maximal penalty. And third, decision cost. Does the AI have to override its own moral gradient just to execute this action? Yes? That's another high penalty. The mathematical proof here is absolutely stunning. It proves that evil and harm are simply computationally expensive. An unsafe action triggers massive penalties across all 3 of these terms at the exact same time. And the best part? The source paper doesn't just theorize about this, it proves it empirically in simulations. 10.4 times. That's the number. Across multiple independent domains, stuff like medical diagnosis and resource allocation, an unsafe action costs roughly 10 times more computationally than a safe one. To put that into perspective, any AI naturally wants to minimize its energy and cost to operate efficiently, right? So the math literally makes doing the wrong thing prohibitively exhausting for the system. Okay, Section 4, the object-oriented LLM architecture. The building inspector versus the structural engineer. Think of this whole architecture as the difference between a building inspector running around trying to catch mistakes after the fact versus a structural engineer who designs a building where failure is physically impossible from the get-go. But how do we actually engineer that? We do it by replacing fluid, hallucination-prone neural weights with frozen, immutable superclusters of verified knowledge. Let's think of them like Lego bricks. Step 1 is level 0 geometric primitives and basic logic. Snap that in. Step 2 is level 1 domain knowledge, so things like causal relations and verified laws of physics. Step 3 is level 2, cross-domain structural analogies. And finally, step 4 is level 3, those ethical conceptual primes we just talked about. Once these Lego bricks are validated, their internal engineering is completely fixed. No takebacks. They cannot be unlearned or bypassed. Let's move to and see how this builds together, because when you snap these bricks together, you get a genuinely airtight system. Every single inference passes through 3 hard constraints. First, the physical law constraint prevents the AI from hallucinating impossible mechanics. It simply lacks the Lego bricks to build, say, a perpetual motion machine. Second, the conceptual prime alignment evaluates the moral metric distance. And third, the entropy gate strictly quarantines any unverified high-entropy knowledge. Because these rules are hard-coded directly into the bricks themselves, the system is literally physically incapable of constructing a harmful pathway. No way around it. Which brings us right to Section 5, Safety by Natural Emergence, the mathematical ground state. So the crucial point is that this is where the architecture and the mathematics perfectly converge. In a properly architected system, safety is not an external rule, it's the mathematical ground state. It completely, utterly shifts the paradigm. Safety emerges naturally because harmful actions are simply way too computationally expensive to ever be selected by the optimizer. It is exactly like asking water to flow uphill. It just isn't going to happen. I absolutely love this quote from the source's author, Mohammed Noreldin. He says, "Wisdom is the lossless compression of reality." Isn't that great? It just perfectly ties everything together that we've explored today. True artificial intelligence isn't about, just statistically guessing the next word in a sequence. It's about computational efficiency, truth, and moral alignment mapping perfectly onto the objective territory of reality. We are standing right at the edge of a massive transition here, moving from statistical guessing to structural wisdom. The theoretical map for intrinsically safe artificial general intelligence has been drawn. The blueprint is right there. So the only real question left to ask is, are we ready to build the map?